Today we're going to focus on parallelogram. Oh, I do not want yellow.
What's wrong with yellow?
You guys don't need to be talking out. Thank you. Quiet. Focus. Hurry up. Get to your seats. We're doing parallelograms. And we're going to do a bunch of properties there. So first we're going to figure out, well, how do we know if something is a parallelogram? Well, just pay attention, please. So let's define parallelogram. A parallelogram is a quadrilateral. So that means 4 sides, 4 angles. Alright, so that'll be our first thing. If we don't have 4 sides and 4 angles, then we definitely cannot be a parallelogram because we're not even a quadrilateral. So that's the first thing. The next thing is the opposite sides. I don't need a plural there. The opposite sides are parallel. And also, the opposite sides are congruent.
Is this the definition of a parallelogram?
Yes.
Okay.
Okay? But it's mainly this first part, the opposite sides are parallel. So if we have a 4-sided shape with opposite sides that are parallel, we have a parallelogram. So each one of these is a parallelogram. Here's the parallelogram. Those opposite sides. Do you see what I mean? This side. Here, I'll do a color. This side is congruent to this side in parallel. Okay, so we can mark that. So I'll mark it. The hash mark means that they're congruent, and the arrow means that they're parallel. And these other two, I'll do double hash. Those are also congruent, and they are also parallel. So if I needed for some reason to prove that something is a quadrilateral, I need to show that the opposite sides are parallel, which means they have the same slope. So the opposite sides, if we put it on graph paper, have the same slope. Okay. Well, what else could we possibly find out about a parallelogram? Well, we have the opposite sides are congruent and they're parallel, but what if, I'll let you finish that up. But what if we have, which by the way, is this a parallelogram that I'm drawing right here?
No.
Why do you say no?
Yeah, he doesn't even finish.
Before I even finished drawing it, we've decided no. Is that a parallelogram?
Yes.
Well, it appears to be, but if I mark it,
No.
why do we say no now?
Because it looks like a rhombus.
Okay, are these, I've marked it. Are the opposite sides congruent?
Yes.
Parallelogram. If the opposite sides are congruent, it's a parallelogram. I would argue it is not possible to have the opposite sides congruent and not parallel.
Aren't you cool?
Okay. Here, let's try a case. Let's say that we have slanted sides. We could say that those are obviously not parallel, but could those be congruent? Sure, I'll mark them. There, they're congruent. But now take a look at this side and this side. Those two sides are parallel, but they are not congruent, right? I suppose we could run through a proof of that, but I'd prefer not to. We'll just take my word for it. You can't have the opposite sides be congruent but not parallel. So that's the case if they're both. I need both of them, both pairs. Okay, anyways, so let's say I have a parallelogram. And now, watch what I draw. See if we can remember our term. What is that I just drew?
Transversal.
It is. It could be a transversal, but that's not what I'm.
It's a diagonal.
It's a diagonal. There we go. And I have 2 diagonals in this parallelogram. There we go. 2 diagonals. What if I said to you those diagonals bisect each other?
It would be radical.
And it sets us up for Sets us up for some algebra. The diagonals bisect each other. Now, I wonder if we could prove that. So if we have a parallelogram, then we have those sides are congruent. This would be a transversal, okay? So that means I have alternate interior angles, and this is a transversal, which means I will have alternate interior angles right here. So these two triangles are congruent by side angle side, or angle side angle. So I have angle side angle. Well, that means their corresponding parts are congruent. So that means this is congruent to this, bisected. This is congruent to this, bisected. So proof by listening to me that those diagonals bisect each other. So what am I getting at though? All right, let's take a look at an application, because I just proved it to you somewhat. But let's say that we have a nicely drawn view. Wow, that's actually jinxed it. Let's say this side is 5. What's x?
5.
Okay, let's say this side is 4. What's y?
4.
Okay, because they bisect each other. So, that's if I have a parallelogram.
So that's the actual fact, not just a given.
Right. That is a fact of parallelograms, that the diagonals bisect each other. Why is that a fact? I just proved it right here. That was why I did all this marking said angle side angle. So we just proved that. All right, let's say I have this other parallelogram here. It's not quite as nicely drawn. And we'll say that we have parallelogram. Now we're going to use this symbol to mean parallelogram. It's kind of hard to draw, but parallelogram. I'll have parallelogram ABC, D, with AC equals 12 and BD equals 10. What's X and Y? Okay, what's X?
6.
6. And what's Y?
5.
5. Pretty easy, because the diagonals bisect each other. We also have some things that happen to our angles, and we actually introduced this yesterday. So let's take a look at the angles more closely. The adjacent, or actually they aren't really adjacent, the consecutive angles in a parallelogram are supplementary. And the opposite angles in a parallelogram are congruent. So let's take a look at the picture of that. Well, look up and make sure that you inspect this the way in. This angle is acute. Do you see that this angle is also acute?
Mm-hmm.
Those are opposite. They appear, that's not a good way to reason, but they appear to be congruent. And notice this angle right here is obtuse. This one is acute. They appear to be supplementary. Now, rather than go through the proof of that, let's just take a look at this. So this is 111 degrees. What is x then?
111.
X is 111 degrees. Okay? Y. What's y? Well, I could look at it from this angle or this way. What's y?
69.
I would do 180 minus 111, and what do I get?
69.
Okay, so y is 69. Then what's z?
69.
The opposite angles are congruent. So try that on your own. I'll give you one angle. Let's say I give you, this one is 50 degrees. I want you to find X, Y, and Z. All right, what do you get for Y, or X? Let's get X first. What's X?
130.
130. Which means Y is,
130.
and Z is
50.
50. Good. The next thing, I'm actually, let's practice this before I get the next thing. Let's go back to the diagonals a little bit. All right, so the diagonals bisect each other. So let's say this piece of this is 3y minus 7, and this one is 2x. And I'll do the next pair in green. Let's say this one right here is x plus 1, and this piece right here, let's say that's just y. So if these diagonals bisect each other, write a formula or equation that associates the two pieces that are in red.
Sir?
They should equal each other.
They should equal each other, so 3y minus 7 should equal
2x.
okay? And the things in green,
X plus Y equals...
X plus 1
equals Y.
okay. So now I have two different equations with two different variables. So from algebra class, we are going to have to solve the system. Notice that y equals the quantity x plus 1. Do you see that?
Yeah.
I can take all of that quantity and put it in for y over here. So I have 3 times quantity x plus 1 minus 7 equals 2x. You, for the most part, probably will not get any as difficult as this, but we do need to remember how to solve a system. If we have two equations with two variables in them, we need to solve them with the substitution method. We distribute the 3. Now what?
You can simplify it,
Okay, so we get 3x minus 4 equals 2x.
and then you can subtract 2x and add 4.
Yep, we'll subtract the 2x. We'll add the 4. So x equals 4.
So x plus 1.
So that means
5.
y is 4
5.
plus 1, which is 5. Okay?
Please leave that up there. Thank you.
Let's try another one. Are you ready? Okay.
I've written down the problem so you can go and I can go back on YouTube and finish that out. So.
All right. Here's another diagram. See if you at a minimum can set up what the equations would be. So you will need a system for this one. If I can find it again.
Don't find
Okay,
it.
here we go. This piece will be A plus 2. This will be B. Right here will be A. And this little piece right here, 2B minus 8. See if you can set that one up. Okay, what do you set up Zoe.
Okay. A plus 2 equals B.
Yes.
And
And?
A equals 2B minus A.
Alright, so we've at least set it up. Now the question is, how am I going to solve that? Well, it looks like, see, this one's already solved for B. I could take all of this A plus 2 and replace it for B over here. Notice when I replace it, I'm going to put it into parentheses. Now what do I do?
Distribute.
Distribute.
Oh.
See, substitution method from last year from algebra class. Now, I'm going to combine. I will subtract this A and add that 4. So I get 4 equals A. Alright, so now I have A. How do I get B? Well, I take this 4 and I put it in over here. So B equals 4
6.
plus 2. So B is 6.
Not as complicated.
Why is it 8?
Huh?
8.
What about the 8?
What did you do with that?
Okay, I have minus 8 right here. 4 minus 8 is negative 4. Okay. Alright, we have one more thing to talk about today before we practice, and also make sure you have your note cards ready so that we can do something with those. I want you to actually figure this little piece out mostly on your own. So draw, let's say, 4 lines, all parallel. So you have notebook lined paper, that should be fairly easy to do. Draw 4 lines that are all parallel and equally spaced. Alright, look up here. I see a little bit of extra talking. Look up here. Let's have a transversal. One going straight down. Okay, now you did this on lined paper. So let's say that you skipped every other line. Let's say you did that. Then this would have a length of 2. This would have a length of 2. And this would have a length of 2, right?
Right.
Okay. Let's say I have another transversal, say over here. Alright, if I know these lengths are 2, what do you know about each of these lengths?
They're equal.
They are all equal, and in this case, because this one's also straight down, they are also 2s, right? Does that make sense?
Yes.
Yes.
Okay. Now, this one, let's see if you can see it. What if that second transversal, what if I made it tilty? Do you think each of these are the same? They aren't 2. They can't possibly be 2 because it's all slanted now. But would they all be the same?
You just said that
I didn't say that they were 2,
What if they were all 1.3 is what
but
it's
could
asking.
they be, say, 2.5? Could they all be 2.5? Yes.
Yes.
Yes, in fact they are. Now if you don't believe me, just listen, draw the diagonal through it, take a ruler and measure, you'll find you should get the same measurement for all of them. Alright, what if it's even steeper? Alright, could these all, if that's 3, then what's x?
3.
Then what's y?
3.
Alright? Pretty simple there. The reason is because these are all on the same all on the same parallel line. So we have equal angles here, right?
Yes.
And then we could form a bunch of triangles, but I don't want to go through that. So, if, using this similar diagram here, if I have on one of these, I say each of these are 4. Well, I don't know that one, so I'll say that's 4. And I say this one's 3. What's x and y? 3. They all have to be equally distributed. If one transversal cuts into equal increments through a bunch of parallel lines, then any other transversal will also cut it in equal portions, be cut into equal portions. All right, we'll stop right there.